everyone, welcome back to my channel. In this video, we are going to solve problems on radius of curvature for the Cartesian curve. Here is the first problem. Find the radius of curvature for the curve y is equal to a into log of secant x by a at any point x comma y. Here they have given at any point x comma y we have to find the radius of curvature for the given Cartesian curve. We already discussed in the previous video. The formula of radius of curvature in Cartesian form is given by rho, which is equal to 1 plus y1 square whole power 3 by 2 divided by y2. Here to find the radius of curvature, first we have to find y1 and y2, that is first order and second order derivative for the given Cartesian curve. Here first take the given curve y is equal to a into log of secant x by a. Here to find y1, we have to differentiate this y with respect to x. We get y1 value as, here a is constant, take as it is, into differentiation of log of secant x by a. This is of the form log x. Differentiation of log x is 1 by x. Hence we get 1 by secant x by a into, again we have to differentiate secant x by a. We get secant x by a into tan x by a into, again we have to differentiate this x by a term. We get 1 by a into differentiation of x is 1. This is our y1. Here a gets cancelled and secant x by a gets cancelled. Hence we get y1 value as tan x by a. This is our y1 value. After finding y1, we have to find y2. For that again we have to differentiate with respect to x. We get y2 value as, here differentiation of tan x is secant square x. Hence we get differentiation of tan x by a as secant square x by a into, again we have to differentiate this x by a term also. Hence we get 1 by a. This is our y2. After finding y1 and y2 value, we have to substitute in the formula of radius of curvature in Cartesian form. Hence we get rho value as 1 plus y1 square is nothing but tan square x by a whole power 3 by 2 divided by y2 is 1 by a into secant square x by a. Here we all know that 1 plus tan square x is nothing but secant square x. This is from the trigonometric identity formula. 1 plus tan square theta is secant square theta. Hence we get in the place of 1 plus tan square theta, here we have 1 plus tan square x by a. Hence we get secant square x by a whole power 3 by 2 divided by, if we take a to the numerator, hence we get rho value as a into secant square x by a whole power 3 by 2 divided by secant square x by a. Here this is of the form secant x by a whole power 2 into 3 by 2. Here we can cancel these two terms here. Hence we get a into secant cube x by a divided by secant square x by a. Here secant square x by a, 1 secant square x by a gets cancelled. Hence we get rho value as a into secant x by a. That is secant square x by a, we can write it as secant x by a whole power 2. Secant x by a whole square into 3 by 2. Here we can cancel 2 term here and the remaining will be secant cube x by a. Divided by secant square x by a is 1 secant square x by a gets cancelled. Hence we get rho value as a into secant x by a. Hence we get the radius of curvature value as a into secant x by a. Hence this completes the problem. Here is the next problem. Find the radius of curvature of the curve x cube plus y cube, which is equal to 3a xy at the point 3a by 2, 3a by 2. Here they have given at the point 3a by 2, 3a by 2. At the point this, we have to find the radius of curvature for the given Cartesian curve. Here what's the first step? Take the given Cartesian curve, that is x cube plus y cube, which is equal to 3a xy. Here to find y1, we have to differentiate this term with respect to x. Hence we get 3x square plus differentiation of y cube is 3y square into, again we have to differentiate y with respect to x, that is dy by dx, which is equal to 3a is constant, take as it is, into, here x and y both are function, hence we have to apply product rule over here. Take y as first function and x as second function. We get first function into differentiation of x is 1 plus second function into differentiation of y is dy by dx. Here take dy by dx as y1 and cancelling the 3 term here, we get x square plus y square into y1, which is equal to a into y plus x into y1. Here rearranging the term, take y1 term to the left hand side and the remaining term to the right hand side, we get y square minus ax into y1, which is equal to ay minus x square. Hence we get y1 value as ay minus x square divided by y square minus ax. This is our y1. But we have to find y1 at the point 3a by 2, 3a by 2. Substituting x and y value as 3a by 2, we get y1 value as a into, here in the place of y we have to substitute 3a by 2 minus, here 3a by 2 whole square divided by 3a by 2 whole square minus a into 3a by 2. Here simplifying the term we get, here in the numerator we have 3a square by 2 minus 9a square by 4 divided by 9a square by 2 minus 3a square by 2. Here in the numerator and denominator both have same values, hence we get y1 value as minus 1. This is our y1 value. That is, if we take the LCM and simplify, we get 12a square minus 18a square divided by 8 divided by 18a square minus 12a square divided by 8. Here 8 gets cancelled. In the numerator we have 12a square minus 18a square divided by 18a square minus 12a square. We get the value of y1 as minus 1. This is our y1 value. Next step, we have to find y2 value. For that, take the given equation 1. That is, from the equation 1 we have y1 value as ay minus x square divided by y square minus ax. Here again we have to differentiate this y1 with respect to x. We get here y1 value, this is of the form quotient rule. Hence we have to apply quotient rule over here. That is, what's the quotient rule? Denominator into derivative of numerator minus numerator into derivative of denominator divided by denominator whole square. This is a quotient rule. That is, y square minus ax, denominator is y square minus ax into derivative of numerator, that is a into differentiation of y is y1 minus differentiation of x square is 2x minus numerator, that is ay minus x square into derivative of denominator, that is y square differentiation is 2y into, again we have to differentiate y with respect to x, we get y1 minus ax differentiation is a divided by y square minus ax whole square. This is our y2. Next we have to find y2 at the point 3a by 2, 3a by 2. Substituting x and y values 3a by 2, we get 3a by 2 whole square minus a into 3a by 2 into a into, here y1 value is minus 1. We already know the value of y1 is minus 1 minus 2 into x value is 3a by 2 minus a into y value is 3a by 2 minus 3a by 2 whole square into 2 into 3a by 2 into y1 value is minus 1 minus a divided by 3a by 2 whole square minus a into 3a by 2 whole square. Simplifying the term, we get in the numerator we have 3a by 2 whole square is nothing but 9a square by 4 minus 3a into a is 3a square by 2. Here taking the LCM as 4, we get 9a square by 4 minus 3a square by 2 is 3a square by 4 into, here a into minus 1 is minus a, minus here 2 gets cancelled, minus 3a, minus a minus 3a is minus 4a minus 3a, here also we have to take the LCM and simplify, that is 3a square by 2 minus 9a square by 4, hence we get minus 3a square by 4 into, here 2 gets cancelled, minus 3a minus a is minus 4a divided by 3a by 2 whole square minus 3a square by 2 whole square. Here 3a by 2 whole square minus 3a square by 2 whole square, that is 3a by 2 whole square is 9a square by 4 minus 3a square by 2. If we take the LCM and simplify, we get 3a square by 4 whole power 2. That becomes, here 4 gets cancelled, here also 4 gets cancelled. The remaining is minus 3a cube minus, here minus into minus plus, hence we get minus, here 4 gets cancelled, we get 3a cube. Hence we get minus 3a cube divided by, here 3a square by 4 whole square is nothing but 9a power 4 divided by 16. Hence we get minus 3a cube is minus 6a cube divided by here 9a power 4 divided by 16. Hence if we simplify the term, we get minus 32 divided by 3a. This is our y2 value. After simplifying this term, we get minus 32 divided by 3a. This is our y2. y1 value is minus 1 and y2 value is minus 32 divided by 3a. After finding y1 and y2, we have to substitute in the formula rho is equal to 1 plus y1 square whole power 3 by 2 divided by y2. Substituting the term, we get 1 plus y1 value is minus 1 whole square whole power 3 by 2 divided by y2 is minus 32 divided by 3a. We take 3a to the numerator. Here we have minus 2 power 3 by 2 into 3a divided by 32. Hence we get here 2 power 3 by 2, we can split it as 2 into root 2. Hence we get minus of 2 root 2 into 3a divided by 32. Here cancelling the term 2 and 32 and simplifying, we get the rho value as minus 3a by 8 root 2. This is our rho value. But the radius of curvature value is always a positive value. Hence we get the radius of curvature value as 3a by 8 root 2. We get the radius of curvature value as 3a by 8 root 2 is a radius of curvature value for the given Cartesian curve. This completes the problem. We shall move on to the next problem. Find radius of curvature of the curve a square y, which is equal to x cube minus a cube at the point where the curve cuts the x-axis. Here we have to note that they have not given the point directly. Instead, they have mentioned that the given Cartesian curve cut the x-axis. That means here this x-axis and this y-axis, the given curve cuts the x-axis means this is a figure represents the given curves cut the x-axis. The given curves cuts the x-axis means y coordinate is 0. Hence we get the required point as a comma 0. Here y coordinate is 0 here. Hence we get the required point as a comma 0. Here what's the first step? We have to take the given Cartesian curve a square y, which is equal to x cube minus a cube. Here in the next step we have to differentiate this curve with respect to x. We get here a square is constant, take as it is, into differentiation of y is y1, which is equal to x cube differentiation is 3x square minus here differentiation of constant is 0. Rearranging the term, we get y1 value as 3x square divided by a square. Here this is a y1. In the next step, we have to find y1 at the point a comma 0. Substituting x value as a and y value as 0, we get 3a square divided by a square. Here a square gets cancelled. Hence we get y1 value as 3. This is our y1 value. After finding y1, we have to find y2. For that, we know that the y1 value is 3x square by a square. In the next step, we have to differentiate this y1 with respect to x. Hence we get y2 value as 3 by a square constant, take as it is, into differentiation of x square is 2x. Here this is our y2 value. Here y2 at the point a comma 0, substituting x value as a and y value as 0, hence we get 3 into, here in the place of x we have to substitute a, hence we get 6a by a square. Here a gets cancelled, hence we get y2 value as 6 by a. This is our y2. After finding y1 and y2, we can substitute in the formula of rho, that is 1 plus y1 square whole power 3 by 2 divided by y2. Substituting the value, we get 1 plus y1 is 3 square whole power 3 by 2 divided by y2 is 6 by a. Here take a to the numerator, hence we get here 1 plus 9. 3 square is 9, 1 plus 9 is 10. 10 power 3 by 2 divided by 6 by a. If we take a to the numerator, that becomes 10 power 3 by 2 by 6 into a. We can split 10 power 3 by 2 as 10 root 10. Hence we get 10a root 10 divided by 6. Here if we cancel the term, we get 5 root 10a divided by 3. This is a value of radius of curvature for the given Cartesian curve. That is, radius of curvature for the given Cartesian curve is 5 root 10a divided by 3. This completes the problem. We shall move on to another problem. Show that radius of curvature at the point a comma 0 on the curve y square, which is equal to a square into a minus x divided by x, is a by 2. Here they have mentioned the radius of curvature value is a by 2. We have to show that the radius of curvature at the point a comma 0 value is a by 2. For that, take the given Cartesian curve y square, which is equal to a square into a minus x divided by x. If we take x to the left hand side, that becomes xy square, which is equal to, here take a square inside the bracket, that becomes a cube minus a square into x. Differentiating this term with respect to x, we get here x and y square both are function. So we have to apply product rule, that is first function y square into differentiation of x is 1 plus second function, that is x into differentiation of y square is 2y into, again we have to differentiate y with respect to x, we get y1 which is equal to a cube is constant, differentiation is 0 minus a square is constant, take as it is, into differentiation of x is 1. After rearranging the term, we get y1 value as minus of y square plus a square divided by 2xy. This is obtained because if we take y square to the right hand side, that becomes minus of y square plus a square. If we take 2xy to the right hand side, that becomes divided by 2xy. Hence we get y1 value as minus of y square plus a square divided by 2xy. This is y1. Also we have to find y1 value at the point a comma 0. If we substitute x value as a and y value as 0, hence we get y1 value as infinity. If we take y1 value as infinity, means in the next step we cannot obtain any values. So we have to take another formula to find the radius of curvature in Cartesian form, that is given by rho is equal to 1 plus x1 square whole power 3 by 2 divided by x2. This is another formula to find radius of curvature in Cartesian form in terms of x1 and x2. Previous formulas are of y1 and y2. Here we have x1 and x2. In terms of x1 and x2, to find x1, that is if we take dy by dx reciprocal, we get dx by dy as 2xy divided by minus of y square plus a square. This is our dx by dy. Now we can substitute the point a comma 0. Here if we substitute x value as a and y value as 0, we get dx by dy value as 0 itself. Hence we get x1 value as 0. After finding x1, we have to find x2. For that, take x1 value, that is dx by dy is 2xy divided by minus of y square plus a square. Here both are function, hence we have to apply quotient rule over here. That is denominator into d by dx of numerator, that is 2x into differentiation of y is minus numerator, that is 2xy into differentiation of minus of y square plus a square is here minus y square differentiation is 2y into again differentiation of y is y1. Hence we get minus 2y into y1 divided by denominator whole square, that becomes y square plus a square whole square. And next step, if we substitute x value as a and y value as 0 here, we get minus 2a cube divided by a power 4. This is because here if you substitute y value as 0, this cancel, and here also y value as 0, hence we get minus a square into 2a is minus 2a cube divided by, here y square is 0 and a square whole square is a power 4. That becomes minus 2a cube divided by a power 4. Here a cube gets cancelled. Hence we get x2 as minus 2 by a. After finding x1 and x2 value, we have to substitute in the formula 1 plus x1 square whole power 3 by 2 divided by x2. Substituting x1 value as 0 and x2 value as minus 2 by a, we get 1 plus 0 whole power 3 by 2 divided by x2 is minus 2 by a. If we take a to the numerator, we get minus a by 2. Here this is our rho value. But we all know that the radius of curvature value is always positive. Hence we get the radius of curvature value as a by 2. Here in this problem, we have shown that the radius of curvature value is a by 2. This completes the problem. We shall move on to another problem. Find the radius of curvature of the curve root x plus root y, which is equal to root a at the point a by 4 comma a by 4. Here they have given at the point a by 4 comma a by 4, we have to find the radius of curvature for this Cartesian curve. What's the first step? We have to take the given Cartesian curve, that is root x plus root y, which is equal to root a. Differentiating with respect to x, we get here differentiation of root x is 1 by 2 root x plus differentiation of root y is 1 by 2 root y into differentiation of y is dy by dx, which is equal to differentiation of constant is 0. Here take this 1 by 2 root x to the right hand side, that becomes 1 by 2 root y into dy by dx, which is equal to minus of 1 by 2 root x. 2 gets cancelled. Take root y to the right hand side, that becomes y1 value as minus of root y divided by root x. If we take root y to the right hand side, that becomes numerator of root y. Hence we get y1 value as minus of root y divided by root x. This is our y1. Here we have to substitute y1 at the point a by 4 comma a by 4. Substituting x value as a by 4 and y value as a by 4, that becomes minus of root of a by 4 divided by root of a by 4. Here root a by 4 gets cancelled. Hence we get y1 value as minus 1. This is our y1. In the next step we have to find y2 value. We all know that y1 value is minus of root y by root x. Here differentiating again with respect to x, we get here both are function. We have to apply quotient rule over here. That is denominator into derivative of root y is 1 by 2 root y into differentiation of y is y1 minus numerator, that is root y into derivative of root x is 1 by 2 root x divided by denominator whole square, that is root x whole square. Here root gets cancelled. In the next step, substituting x value as a by 4 and y value as a by 4 here, we get here minus sign take as it is into here substituting x value as a by 4, that is root of a by 4, we can write it as root a by 2. Root 4 is nothing but 2. Hence we can take root x as root a by 2 into 1 by root y is nothing but 1 by root of a by 2. Hence we get 2 by root a into, here we know that y1 value as minus 1. Take 1 by 2 outside into root y is nothing but root a by 2 into 1 by root x, we can write it as 2 by root a. Whole divided by here root gets cancelled. X is our a by 4. Take as it is a by 4. Here 2 gets cancelled. Here also 2 gets cancelled and root a gets cancelled. After simplifying, we get y2 at a by 4 comma a by 4 as 4 by a. This is because here 2 gets cancelled. Root a gets cancelled. That becomes minus 1 by 2. Here also minus 1 by 2. Here minus 1 by 2 is nothing but minus 1. If you take a by 4, here 4 to the numerator, that becomes plus 4 by a. This is our y2 value. After finding y1 and y2, we have to substitute in the formula of radius of curvature, that is 1 plus y1 square whole power 3 by 2 divided by y2. Substituting y1 and y2 value here, we get 1 plus y1 is nothing but minus 1 whole square whole power 3 by 2 divided by y2 is 4 by a. Here if we split 4 as 2 into 2, we get here in the place of 2 power 3 by 2, we can split it as 2 power 1 into 2 power 1 by 2 into a divided by 2 into 2. Here 2 gets cancelled. 2 power 1 by 2 divided by 2 is nothing but 1 by root 2. Hence we get the radius of curvature value as a by root 2. Therefore, the radius of curvature for the given Cartesian curve is a by root 2. This completes the problem. These problems are very important. They have given in examination so many times. Till here we have studied important problems on finding the radius of curvature of a Cartesian curve. In the next video, we shall derive an important formula to find the radius of curvature in polar form.